Hello everyone, welcome back to the channel. So in the last session, we have started discussing about a introduction part of stoichiometry. There we have considered again classification. I have repeated the classification of matter, and even we considered the properties. That is physical properties and chemical properties. The meaning of a physical property and chemical property. Well, so whenever if you want to express any physical quantity, right, physical property, what is necessary? A systematic way or systematic approach is necessary to express a physical quantity. Yes, there are various ways by which the physical quantities or I can say physical properties of a matter are expressed. Yes, one among them is, or I can say the most acceptable one is the international system of units. So all those physical quantities are expressed with the help of, as we said, number and appropriate unit. So this international system of unit, it particularly deals with the expressing the various physical quantities. Okay, expressing the various physical quantities with a number and appropriate unit. So well, this international system of unit is in short abbreviated as SI. Okay, system of international, or it is also called the international system of units. So here, according to SI system, okay, according to SI system, SI international system of unit, or even you can say system international. So according to this international system of measurements, there are seven basic physical quantities. Okay, base physical quantities. How many are there? There are seven base physical quantities: length, mass, time, electric current, temperature, okay, amount of substance, and luminous intensity. So these are the basic fundamental quantities, basic fundamental properties, or I can say base physical quantities of a matter are length, okay, length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Well, these base physical quantities are expressed with the help of symbol. Okay, all these base physical quantities are expressed with a particular symbol. The symbol of these base quantities: length, what is the symbol? Capital L is the symbol. Okay, length is expressed with a symbol capital L. Okay, for mass, capital M is the symbol. Time, capital T is the symbol. Electric current, capital I is the symbol. Temperature, okay, T is the symbol. And amount of substance, N, number of moles, is the symbol, so it is abbreviated with small n. And luminous intensity, IV. Okay, these are the symbols for these base physical quantities. How many physical quantities are there? According to SI system, there are seven physical quantities exist. What are those? Length, mass, time, electric current, temperature, amount of substance, and luminous intensity, and with their respective symbols. Now, if you consider unit, the SI unit of measurement of this physical quantity, if I want to measure the length of any object, length of a matter, according to SI system, the length of any matter is measured with the help of unit meter. So what is the name of the unit? So the SI unit for length, it is the meter. How we are writing? METER, meter. For mass, what is the SI unit? Kilogram is the SI unit. Time, second is the SI unit. Electric current, ampere is the SI unit. Temperature, Kelvin is the SI unit. Amount of substance, mole is the SI unit. Luminous intensity, candela is the SI unit. So what I am specifying? The unit for those physical quantities, base physical quantities. I repeat, length is measured in meter, mass measured in kilogram, time measured in second, electric current measured in ampere, temperature measured in Kelvin, amount of substance measured in mole, luminous intensity which is measured in candela. So these are the SI units of those seven base quantities. Okay, well, further these units are expressed with the help of a symbol. So whatever the SI unit I have written, they are going to express it with the help of a symbol. So how meter is expressed? The symbol for meter is small m. So meter is written. What is the symbol here? Small m is the symbol. For kilogram, kg. So capital K, small g is the symbol. Second, S is the symbol. Okay. Ampere, capital A is the symbol. Kelvin, capital K is the symbol. Mole, okay, mole, MOLE Okay, capital M-O-L-E, sentence form. That mole is the name. If you consider symbol MOL, okay, MOL is the symbol. And candela is the SI unit for luminous intensity. And what is the symbol of candela? Okay, CD. Well, these are the symbols. So according to SI system, or you can see International System of Units, there are 7 base quantities. They are length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Well, and their respective units and the symbols. It is very very important. Please remember this. Well, now the definitions of SI base unit. Definition for those SI base units. Whatever the 7 base units we have considered, we have to look for the definitions. The unit of length. Okay, if we consider unit of length, length is one of the base unit. What is the unit for length? Meter is the, okay, meter is the unit for length, right? Well, now how we are going to define the meter? So the meter is the length of a path. So what is meter? Meter is the length of a path, length of path traveled by light. So please remember what is meter, what how we are going to define this base unit means. The meter is the length of path traveled by light in vacuum. So please recall the things. So what we are I'm saying, meter is the length of path traveled light in vacuum. So we know the meaning of vacuum. Vacuum means it is the absence, okay, absence of air. Absence of air or any material particle is considered as a vacuum. So during a time interval of, so what is the time interval here? So during a time interval of 1, okay, so during a time interval of 1 divided by 299, okay, what is the value here? 1 divided by 299 792 458 of a second. Okay, so just I will repeat the definition of meter. What is a meter? Meter is the length of path traveled by light in vacuum during a time interval of 1 divided by 299,792,458 of a second is called meter. Okay. Well, the unit of mass. If you consider unit of mass, what is the unit of mass? Mass is going to express it in terms of kilogram. Kilogram is the unit. Is what is kilogram actually? So the kilogram is the unit of mass. Okay, kilogram is the unit of a mass. It is equal to the that 1 kilogram, which is equal to mass of international prototype of kilogram. So that 1 kilogram is actually equal to, it is equal to mass of the international prototype of a kilogram. Well, yes. The next one, unit of time. So what is unit of time? Second is the unit of time, right? Second. Time is expressed in terms of second. Yes, what is second actually? The second is the duration of, okay, second is the duration of 9, okay, 919263, okay, 919263 1770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of cesium 133 atom. So I just go through the definition again. The second is nothing but it is the duration of 919263 1770 periods of the radiation corresponding to the transition between two hyperfine levels of ground state of cesium 133 isotope. It is the second. Well, next thing, if you consider electric current, what is the electric current? Its unit is ampere, right? Ampere is the unit. Well, what is ampere here? Ampere is that constant current which, if maintained into two state parallel conductors of infinite length of negligible circular cross section and placed 1 meter apart in vacuum, would produce between these conductors a force equal to 2 into 10 raised to minus 7 newtons per meter per length. So what is ampere? Ampere is that constant current which, if maintained in two state parallel conductors of infinite length of negligible circular cross section and placed 1 meter apart in vacuum, and would produce between these conductors a force which is equal to 2 into 10 raised to minus 7 Newton per meter, okay, Newton per meter of length. It is the ampere. Well, next one, if you consider unit of thermodynamic temperature. So what is the unit for temperature? Kelvin. So what is Kelvin here? The Kelvin is the unit of thermodynamic temperature is the fraction of, okay, what it is? Kelvin is the fraction of 1 by 273.16 of thermodynamic temperature of triple point of water. So what it is? It is the fraction of 1 by 273.16 of the thermodynamic temperature of triple point of a water. So triple point of water is the point where all three states of a matter coexist: solid, liquid and gaseous state, so called triple point. Okay, well, next coming to the unit of amount of a substance. Well, what is the amount of substance? Its unit is mole. So what is mole? Mole is nothing but it is the amount of substance of a system which contains as many elementary entities as there are atoms in. Okay, I just repeat, mole is the amount of substance, okay, which contains as many elementary entities as there are atoms in how much? In 0.12 kilogram of carbon 12 isotope, okay, and its symbol is MOL. So repeat, what is more? It is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon 12 isotope. It is the mole. Well, the another way to define mole is used the elementary entities as must be specified and maybe atoms, molecules, ions, electrons, other particles are specified group of such particles. So here mole, if you use the mole, is the elementary entities as must be specified and it may be atoms or it may be molecules or it may be ions or it may be electrons or any other particles or any specified groups. Okay, well, and if we consider unit of luminous intensity, what is the unit for luminous intensity? It is the candela. So yes, what is candela here? The candela is the luminous intensity in a given direction. A source that emits monochromatic radiation of frequency 540 into 10 raised to 12 hertz, okay, is a given that is a source that emits monochromatic radiation of frequency. What is the frequency of that radiation emitted? Which is equal to 540 into 10 raised to 12 hertz, and that has a radiant intensity in that direction of 1 by 683 watt per steradian. So what is the radiant intensity? The frequency which is equal to 540 into 10 raised to 12 hertz, and that radiant intensity in that direction which will be equal to 1 by 683 watt per steradian. So it is about candela. Well, now if you consider the prefixes which are used during the simplification while representing the values. So if you use 10 raised to minus 24, okay, if the any value, if you use 10 raised to minus 24, and what is the prefix must be used? It is named as a yocto, and symbolically capital Y is the symbol, okay, and 10 raised to minus 21 gypto, capital Z is the symbol. If you use 10 raised to minus 18, okay, 10 raised to 18 is the multiple, then it is named as auto, and symbol small e is the symbol. And if it we use 10 raised to minus 50 femto, small f is the symbol. 10 raised to minus 12 pico, capital P is the symbol. The next one, if you use 10 raised to minus 9, it is named as a nano, prefix nano, and symbolically small n is used as a symbol, and 10 raised to minus 6, it is called micro, and mu is the symbol. Well, next one, 10 raised to minus 3, milli is the prefix, and small m is the symbol. Well, similarly, if you go for next one, say 10 to minus 2, so centi, small c is the symbol, 10 to minus 1, okay, deci, small d is the symbol, okay, deca, da is the symbol, then 10 to 2, hecto, h is the symbol, 10 to 3, kilo, okay, small k is the symbol, 10 to 6, okay, mega, and capital M is the symbol, 10 to 9, giga, and capital G is the symbol, 10 to 12, okay, tera, capital T is the symbol. Then next one, 10 to 15 plus 15, that is peta, and capital P is the symbol, 10 to 18. I'm talking about the multiples and prefixes used and the symbols. 10 to 18 hexa, and capital E is the symbol, and 10 to 21, so zeta is the prefix and z is the symbol, and 10 to 24 yoto, small y is the symbol. So these are the most of the prefixes, that is multiples, which are used to come across during expressing any physical quantity. So it is very very important to remember the multiples and its prefix and corresponding symbol used. Well, okay, next one, coming to the multiple choice questions. Well, here, which of the following is not a basic unit, basic fundamental unit according to SI system? So first length, second mass, third time, and fourth one density. So if you consider according to SI system, what is a basic unit? Length is a basic unit, mass is also basic unit, yes, time is also basic unit. And what about density? Density is not a basic unit, but it is a derived physical quantity. Okay, it is a derived physical quantity. Then what is the answer here? Density. So which of the following is not a basic unit, they are asking. So density is not a basic unit, it is a derived unit. Well, yes. Next question. What is the unit for luminous intensity? They are asking unit for luminous intensity. First option ampere, second one mole, third option candela, and fourth one Kelvin. So when you look at the units, so remember that chart, first one. So ampere is the basic unit for what? Okay, it is unit of electric current, mole amount of substance, Kelvin temperature. So candela is the answer. So candle is the unit for luminous intensity. And what is the symbol? Small c, small d, cd. Next one. What is the symbol for electric current? They are asking symbol for electric current. That is symbol of unit of electric current. Capital L, capital T, capital M, then D option, capital I. Yes, what is the answer? I, electric current. I is the symbol, right? Yes. So with this, I'm going to conclude about this session. Again, in the next session, we go for other part. Well, thank you. Be safe.
Yeah.